So, good afternoon, everybody. I am Alessandro De Luca from the University of Campania Luigi Vanvitelli, and today I'm going to present the work entitled Fatigue Behavior of Hybrid and Bonded Single Lap Joints made of composite materials. So, nowadays, composite materials are attracting several engineering fields thanks to their advantages in terms of high specific strength with respect to the conventional materials like, for example, metallic ones. However, their application, as well known, can become very challenging due to several aspects concerning, for example, the joining operations. Among the several types of joining operation, we can speak about bonded, bolted, and hybrid joints. Bonded joints doesn't need drilling operation, and it allows the distribution of the load over a larger area with respect to the mechanical joints. In contrast, adhesive joints are sensitive to environmental conditions, humidity, in-service temperature, and surface treatment. And of course, the adhesive layer can be affected by some cracks propagating inside the layer during the operating life. So the use of both mechanical fastening and adhesive layer is often adopted to take advantages by both techniques and to improve the safety against possible not expected damages and defects that can lead the joint to the collapse. So here you can find details about these specimens. We developed and manufactured two types of joints. In particular, we have a bonded and hybrid bonded bolted types of joints. All details about the dimensions are shown in this picture, and with respect to the material, they were made of carbon fiber reinforced polymer materials in the form of carbon prepreg layers with stacking sequence of 0.45 45 minus 4 times symmetrics. With respect to the bolt, a high-lock bolt was used which allowed to introduce a controlled torque inside the bolt. You can find also details about the hole and also about the adhesive which was used to attach the other ends. It was a two-component epoxy adhesive by 3M. Concerning the experimental test, two types of tests were performed, the static test and the fatigue test. In particular, concerning the static test, 4 tests were performed, 2 for the bonded joints and 2 for the hybrid joints. Whilst concerning the fatigue test, 8 tests were performed on the bonded joints and 6 on hybrid joints. The bonded joints were considered failed when they collapsed, while the failure criteria used for hybrid joint concerned the propagation of cracks inside the adhesive layer, and in particular when such cracks reach a value of 12 mm, which was measured through the liquid penetrant testing method. And in particular in this picture you can find also the details about the execution of the test, and in particular the load levels, the R parameter, and the frequency of the test. Here you can find the facility used for the execution of the test, and in particular concerning the detection of the crack initiation, the joint was equipped with back-face string gauges. And in particular, after the fatigue test, some hybrid specimens were tested in order to evaluate the residual strength, and in particular for the fatigue test, the runout was fixed at 10 to the power of 6 cycles. Concerning the results, you can find here the load versus displacement curve for both hybrid and bonded joints, and in particular, according to this picture, we can find that the maximum load supported by the adhesive layer in hybrid joint is lower than the one supported in the bonded joint. Moreover, we can observe that the maximum load supported by hybrid joint is higher than the one supported by the bonded joint of about 15%. Here you can find results related to the fatigue test. In particular, in blue you can find the points related to the experimental data for the bonded joint. In red you can find the points related to the hybrid joint, and with the black arrow you can find the runout for the test. And here you can observe that for high load higher than 8 kN, the presence of the fastener didn't improve the fatigue life, whilst for lower load, lower than 4 kN, the presence of the fastener has an influence on the fatigue behavior of the joint, and in particular it improves the fatigue life of about 10 times. Herein you can find the results related to the assessment of the residual strength of hybrid joint. And in particular, we can observe how the residual strength of hybrid joint decreases as the fatigue life decreases. Moreover, we can observe how the maximum load supported by the adhesive layer decreases as the fatigue life decreases. And in particular, higher load produces more severe cracks. So, in conclusion, we can say that in this research activity, we perform static and fatigue tests to evaluate the behavior of both bonded and hybrid joints. In particular, we can summarize also the results, and we can say that the maximum load supported by the adhesive layer in hybrid joint was found to be lower than the one supported in bonded joint. Moreover, it was also found out that the presence of the fastener didn't improve the fatigue life for higher loads, whilst in contrast, for lower loads, the fastener has an influence on the fatigue life, and it improves the fatigue life of about 10 times. In conclusion, we can also say that the residual strength of hybrid joints decreases as the fatigue life decreases. Thank you for your kind attention, and feel free to ask questions through the email shown in bottom.